Hello, it's Duncan. One of our jobs as engineers is to make sure the systems that we implement work. Here on Gilded Rose, we've been using test-driven development to make sure that we have a good test suite. But it has to be said that we don't actually at the moment have any monitoring, which is to say that we know that our tests run, but we don't know that the actual system does. Now, we're lucky enough to have an on-site customer, the owner of Gilded Rose, and she, we think, would tell us if she saw anything wrong, but we'd also like to be ahead of that curve. And in particular, when we update our software, we'd like to know early rather than late that it isn't working. So today we're going to look at adding some monitoring. Now we can monitor the normal operation of our software, but perhaps most importantly, we should be monitoring the abnormal operation of our software, which is to say, if it goes wrong. And the most likely way for a Kotlin program to go wrong is for it to throw an exception. So the first thing I think we're going to do is to look at what would happen if our code failed. Now in order to do that, what we're going to do is we're going to add into our routes a special route whose job it is to fail. So we could call it error, and we'll bind get to a handler, and all the handler is going to do is throw an error by the Kotlin error statement, and we'll say deliver it. Okay, let's run up our server, and then we'll hit that page, that route, and see what we get. Okay, so you can see that we've got a stack trace here in our output. You can see here that status for response was 500, which is internal server error. Now we didn't do that, so we have to ask the question, what did? And if we look through the stack trace, we see here this server filters catch all. And so it looks like some part of HTTP4K, which is our server library, is catching exceptions for us. So let's go and have a look at that. Copy that there, and we will find that. Okay, here it is. You can see the internal server error there, and you can see that here it's building our stack trace in order to send it out in response. So this is pretty likely the thing that's responsible for that behavior. Now, also there's a comment here saying, we suggest this filter is not used in public-facing services so that internal error stacks are not exposed. Now that's good advice, because we probably don't, if this server was on the internet, want our internals exposed so that people could see what technologies we're using and maybe find some exploit. So we'd like to remove that behavior, and the writers of HTTP4K suggest we do that by using this as a template. And what I think they mean by that is copy and paste it. So let's copy and paste it. Where to? Well, the answer is let's put it in a test for now so that we can mess around with it. So I'm going to create a new package, and this is going to become Gilded Rose HTTP4K. So these are things that are actually sort of extending that library, making use of it alone, and that we might share between projects at some point. And in here, a new test, and we're going to call it catch all filter tests. Add that, and as we suggested, we're going to copy and paste this into here so we can run our version. Okay, so what do we want this test to show? Well, we want it to show that it logs errors. So let's write ourselves a test. It logs on error. And maybe we should say exception. How do we use filters? Well, first of all, we need one. So we'll create one. It's worth saying at this point that HTTP 4K has a bit of a strange convention here. Instead of having a class as catch-all, we have an object. And the object has an invoke method. So what we're actually doing here is we're calling catch-all invoke. And that thing is returning a filter. So it's really just to get around for the fact that if we had a top-level function with a capital letter, IntelliJ would complain. Other options giving the same syntax would be that we could have had a class here. So we could have said we have a class catch-all that implements filter with a constructor. So that would have compiled in the same way. Or we could have had a function with a capital letter that returned a filter. And that would also compiled, but IntelliJ would have complained that this function has a capital letter, and that's not normal Kotlin. So instead of that, we have this convention here of an object with an invoke method so that we appear to be creating an instance. Well, we are creating an instance, but we appear to be calling a constructor. But we actually just have an anonymous type here. Okay, diversion over. What do we do with the filter? Well, we need a handler underneath the filter, if you like, to be filtered by it. So this is our handler. And if we tell IntelliJ that that's an HTTP handler, we can define it with a lambda to just throw some exception through the error statement. Now we install that to give another handler, the one that we'll actually end up using, by saying we've got a filter, then our handler. And this then is an extension method, so we have to import it. That, if we ask the question, is also an HTTP handler, request to response. So we can invoke it to get a response. So our response is another handler dot invoke, passing a request. A request needs a method. We'll pass in get at the moment, and needs a path. We'll pass in the root. And the catch-all filter we know will return internal server error, so let's assert that. Here's our response dot status. Okay, let's run that test. Good. Now that we know the pattern, we can elide a bunch of these bits. Probably the filter as well. So given a handler, our response is the filter, then the handler, and we can invoke that with a request. A little bit of tidying up here. And so run the tests. Now we should show the other behavior, so let's write another test, which is that it passes out a response on no exception. So if we don't return an error here, but return a response, let's say OK. Then when we make that request, then what we should get out is the response that we returned from our base handler. And that's going to be the whole of our response. run that. Good. Now, of course, we have shown that the correct response is returned, but what we haven't shown is that any logging is happening. In fact, no logging is happening because our actual filter here is printing stack trace that we don't want. So let's work out how to solve that problem. We need to create a logger and interact with it in some sort of way. So let us create a logger. And we'll go to our logger factory and ask it to create a logger for us. Give it a test logger. And then we should be able to pass that to our catch-all, and it should be able to do things for us. Well, we need to, it turns out, do that by hand. And here we've got this parameter that we're not using at the moment, so I think maybe we'll just get rid of that parameter altogether and inline that in there for now. Okay, this is going to be our logger. That will make this pass, but this will stop compiling. We'd better import that. And let's copy that code in here as well. Put that in there. Okay, so now we want to say, well, should we write the test first or should we write the code first? We have a bit of a problem here because this logger is going to print the standard out. Well, let's just see what we're getting, shall we? So first of all, we'll say our implementation wants to be logger.error with some message, which we're going to say is uncaught exception, and the exception that was uncaught. Now we can get rid of that. Now we don't have a body. Now we might want to put a body in actually, so let's say instead of that we'll say something went wrong. Sorry. So at least we'll have something. Okay, so now in our output we can see that in one case we have some logging statements, and in the other case we don't. But that's not a very good test because we had to examine the output manually. What will we do in this situation? Well, we probably reach for a mocking framework to mock our logger. And it's quite a nice way of doing that in Kotlin if you don't want a proper mocking framework. In order to use it, let's pull this out as a field. Delete that one. And then instead of going to the logger factory and creating an actual logger, we're going to fake a logger. And we can do that with a special little function here, which asks Java to create a new instance of our class, in fact interface. So here we can say we want to fake passing it the logger. Now you see that compiles, and the type it returns is logger. And if we run it, if you call any methods on this fake, our faking throws an exception with a to-do. So that's what we're seeing here. An operation is not implemented. That's not very helpful to us, but what we can do now is we can use this to implement an object. So we're going to create an object that implements logger by that fake. So any calls to the logger interface on this object will be handled by this fake, except the ones that we override. And we know here that we are going to call logger error. So let's override that in here. This one. And in here, we could do what we like. So in here, we can say throwable court equals t. Now we know that's not really nullable, and we are going to create a property in this whole test, which starts as null, but may be changed by this code. So that is a var, yes. Okay, don't need that. Now, when this happens then, we would expect to see that throwable court, for now we can just say a certain not null. Throwable court. And when it doesn't log, throwable court should be null. So we've created a little, not really a mock, but a little sort of faking framework here. Let's just see whether that works for us. It does, which is good. Actually, a better name for this would be throwable logged, because that's what we are doing with it. And you can see we could add in test about what message we're putting in here and so on. This is okay, but I think we could do better. Ultimately, our catch-all filter, it is logging for us, but it would be nice to have one that could do other things. So what I think we're going to do is we're going to change it from talking explicitly to a logger to a catch-all filter where we can pass in the behavior that we want if it catches an exception. What would that look like? Let's go down and see what it currently does on exception. That's the body of this block here. So when it gets an exception, it logs an error and it returns some sort of response. So we're going to encapsulate that behavior as a lambda. And that lambda is going to take this exception and it's going to return the response. So what we're going to say is there is this lambda and its type is exception to response. And the implementation of that lambda is this code here. And inside here, this is the exception. I can type. That is going to be logged in here. And this response is the response that's going to be returned from the body of the lambda. That's all good. And all this wiggly lines is IntelliJ saying, well, you've got to return something from here. The thing we're going to return from this exception block is now going to be take the lambda and invoke it with the exception that we called up here. We don't actually want to return with that wants to be the value of this exception handler. And we need to put the equal signs in there. So that is the same behavior as we had before. What we're doing is creating a block of code and we're invoking it as opposed to just invoking a block of code. The implementation will be slightly different, but the effect will be the same, as we can see, because the test pass. Okay, so now what we're going to do is we're going to take this lambda and we're going to make it a parameter to this whole function. Now IntelliJ is clever enough to show us that if we do that, then we don't need this logger anymore. It won't be referenced inside this function. And we'll call this on exception. Okay, so let's go and look at the calling code. And you can see what's happened now is that our catch-all is taking this block of code. Unfortunately, IntelliJ has messed up our imports in 2 places, but it has pulled this block of code that was in here out into the corners. So again, that should be the same code, it should still pass the tests. Splendid. Now a little bit of tidying up. First of all, we can inline this lambda. So when we get an exception, we just call this handler and return this result. And secondly now, we actually don't need a logger in our tests. We don't need a logger in our filter because what actually happens on exception is now entirely parameterized with a function. And in our tests, well, we'd basically be testing this code here in this code here, but those are both in the test. They're not actually anything to do with our production code. So that means that we can get rid of our logger altogether in our tests. Here, and here, and here, and here. Run that. Now we can simplify it even further because we don't actually care anything about the body. Again, that's just being shown. And in fact, we can hard code this in there. And now, in fact, our filter we can pull out as a field in the whole test. And you can see we can do this because the only response that our catch-all filter can reasonably return is either the one from the handler, in the case of there's no exception, this one, or the one that our expression here returns in the case where there is an error. Tidy this up a bit. We're not using it. Now that is a potential place where we could re-implement our code to not pass the right exception in here. We're not actually checking that, but I think that's a small enough problem that we shouldn't need to worry about it. It's nice and simple now, our code. Okay, so we've now implemented a simple catch-all filter. You might think that it would be nice if the HTTP 4K version of this catch-all filter was more like this one, and through the magic of recording this in 2 parts and pull requests, we can make that happen. So if we go to our build file, upgrade the version of HTTP 4K, import. Then if we go to the catch-all filter, but the HTTP 4K version, you'll see that it now has an on-error throwable response and some way of using the original behavior unless we configure it. So that should mean that we can go to our tests now, remove this version altogether, and check that the new HTTP 4K version works as we want it to. So we'll import server filter version and run our tests. Marvelous. So the net result of all this is that we can simply delete our catch-all filter and use the new HTTP 4K version, and everyone in the world is better off. So let's delete that. And now we're ready to try the new version in our production code. This is of course the old version 4.25.7, and here is the new version 4.25.8. It's worth noting there is another difference here, and that is that this version caught only exceptions. So had we used this, we wouldn't get to see things like out of memory and so on that we might reasonably want to log or decide what to do with. Whereas our new version actually catches throwables and passes them to our on-error function. What should we do with those sort of errors? Well, That's a good question, and it depends on our application, but mostly I think we should probably assume that throwables might go away and that things like out of memory will be handled by monitoring our server to check that it has enough memory and killing it if it doesn't. Okay, let's tidy those away and go back to our main. To install the filter, well, we need to create one, so we'll do that in here. Dual, passing it a block that's going to log. So we need a logger. Exceptions logger. And here we'll do the thing we did in the tests. And remember, we need to pass out the response. Pass out the response that we can build with internal server error and the body of our choice. Now to install that, we take our filter and we apply it to our roots. And now if we run up our server, and go to our error page, we should see our logging here, and we should see our message here. And if we go to a non-error page, we should see that and no logging. Now, we're test-driven developers and we just wrote some code without tests. Is that acceptable? I think, personally, for this application, yes. For a bigger application, maybe no. But I think that we are going to want a better interface than the logger to handle these sort of problems. And when we have a better interface, it will probably be better, certainly easier to test it. So the best is the enemy of the good, as they say, and I think we're going to think that it's better to get this into production so we can see problems if we have them, rather than have it hugely well tested, or at least rather than to stick to the law of test-driven development that we can't install any code at all without writing a test thread first. So I think we are done for today. Let us check that in. Next time, I think we will look at what a better interface for handling visibility monitoring of our application would be. If you'd like to see that episode when it comes out, then please subscribe. And if you like this content, I think you'll probably like the book that I wrote in that price called Java to Kotlin, a Refactoring Guidebook. Details of that are down there somewhere. Thank you very much for watching.